So on the right, you see our drone flying, but what's more interesting is on the left, the applied automatic control. You can see that. So in the bottom, you can see the output from the deep neural network, and when it turns deep blue, we find this region and we apply proper automatic level control. So everything is done automatically. The only thing we done in the beginning, we showed where we want to fly, which is shown by the circle. So the red circles tracks the window for which we fearlessly fly towards without any other manual control to the drone. Because this is the best and the only video that we have, I will play it again so that you can watch it in peace. So according to the task defined in the beginning of this presentation, the user only selects the place where they want to fly, and it is the machine that understands, that learned to understand the three-dimensional content of the world around it through the two-dimensional picture. And it flies on its own. Our task is, from having a two-dimensional image, find a third dimension, a depth map of it. In order to train that, we need training data. In other words, if we want our machine to get a depth map for every frame, we first need to give 100,000 of examples of this job done right. So how to do it? The first way would be to take a ruler, and for every pixel in this image, measure the distance between the camera and the place in the real world. Repeat that for every pixel. We have the depth map, and then repeat this for 100,000 of examples. Our rough estimate for that would be 300 years, so we decided to use a different approach. We will be using our structure from motion algorithm. Without any stress in the beginning, we can do whatever movement we want, so we will be moving sideways to create our ground truth, and then we will move towards and backwards from some object, for example, a pillar, hence the name Deep Pillar Learning. And we will be moving precisely according to a well-defined scenario between 0 and 4 meters from the pillar, all the time the same. And this is how we would get a nice depth map for that, but this depth map, because it is structured from motion algorithm, we don't know what's the scale of that. It is a random scale, it is floating, and in order to fix the scale, we will find the histogram of the depths in time, locate the pillar inside, and then normalize this to lie between 0 and 4 meters. And then apply this normalization back to our images, hence having a nice ground truth in the metric world. And only train our network.